Alright guys, so today we're going to be going over smart sanitation. A 3D printed faucet attachment is what we designed by Julia, Alexis, and Izzy.
Everyday surfaces like faucets, door handles, and toilets are major sources of bacteria transfer. Faucets create a hygiene issue. Users turn them on with dirty hands and off with clean hands, leading to recontamination. High touch surfaces carry significant bacterial loads. Faucets can have over 229,000 germs per square inch. Shared environments, especially hospitals, increase the risk of infection spread. Approximately 10.82% contamination rate on hospital toilet door handles. While some modern solutions like sensor based systems exist, they are not always accessible due to cost and infrastructure. There is a need for simple, affordable, and widely usable solution to reduce contact based contamination.
Alright, hello guys, this is Lexi. I'm going to be presenting you guys the proposed solution. So basically, our proposed solution is that we develop a low cost faucet attachment that would require just you using contact with your elbows. This has been seen as in COVID-19 when we did our elbow fist bumps. It's even being practiced right now currently in hospitals. There are faucets that they do use their elbows. And then in other areas where this can be used is teaching children proper hygiene practices, and then also in restaurants as well. The proposed attachment would be made out of plastic, which is sustainable, lightweight, and very affordable. Alright guys, so this is going to be our design drawings. So basically, this is the faucet attachment, and at the top is going to be the elbow piece that you actually use for your elbow, and then the bottom part is going to be the piece that can interchange depending on your faucet. We use a sliding joint to connect both of those so it locks in together.
Here are the results for our project. So this is the 3D printed faucet extender. So you can see this L-shaped piece is the actual extender, and then the other piece is the attachment piece that goes directly onto the faucet. So we used SolidWorks in order to design these pieces, and then we 3D printed them in the DFX lab. And so you can see that this attachment piece, we designed it around a faucet that was in one of our apartments, and it fits onto the faucet with this screw piece that keeps it securely on the faucet. And another note to mention is that the attachment piece can actually be removed and interchanged from the extender piece. And so this allows us to design different attachment pieces that can be used on any type of faucet handle. So this is a video of me using the faucet extender and washing my hands. And then this video showcases the ultrasonic sensor, which will sense your hands as you're washing them. And then the LCD display counts the time so that you're able to see how long you've washed your hands for. And the CDC recommends that you wash your hands for 20 seconds. And so this display will help make sure that you are washing your hands adequately and reducing the spread of germs and viruses. And this video just shows a demonstration of everything combined. So this is me turning on the faucet using my elbow and then washing my hands, and the LCD display showcasing how long I've washed my hands for.
Alright, so next up, I'm going to be going over the code. Alright, so this is the code that you will see essentially on the ultrasonic sensor and the liquid crystal display. I'm going to take you through it very quickly. So basically, we have a timer. We also have a sensor for the ultrasonic sensor, which you can obviously change the sensitivity of it and the range. What's really nice about the liquid crystal display is that it's going to start counting for you and it's actually going to display that. This would be a very good feature if you're teaching your kids proper hand washing. You could even integrate something on the liquid crystal to make it more fun for kids as well, teaching them proper hygiene practices.
So in conclusion, the faucet extender attachment was successful. The design allows the user to easily use their elbow to turn on the faucet when their hands are dirty. The attachment piece is interchangeable, allowing the extender to be used on any faucet handle. The ultrasonic sensor effectively sensed the user washing their hands, and the LCD display counts the time to ensure adequate hand washing. And overall, the technology created offers a versatile and cheap faucet extender that can be used to reduce the spread of bacteria.
Our future work will include expanding the design to include interchangeable attachment pieces for compatibility with different faucet types and geometries, improving the material selection to increase water resistance and prevent corrosion in wet environments. Materials such as stainless steel and engineered plastics are commonly used because they resist degradation from moisture exposure. Integrating internal hardware into the attachment to create a more compact, sealed design that protects electronics from water exposure and environmental damage. Transitioning to a battery power system to eliminate external wiring and improve flexibility and ease of installation. And these are the references we used.